You know, when we think about the Apollo missions, it's easy to assume NASA planned for absolutely everything. But what if the absolute worst happened on that long, lonely trip home from the moon? We're going to dig into this amazing 1971 NASA paper that laid out a life-saving backup plan, one designed for astronauts who were totally, completely on their own.
Okay, just picture this for a second. You're an astronaut. You're hurtling through space, halfway home from the moon in this tiny little can. And then the radio crackles and goes silent. Just nothing. Mission control is gone. You are completely alone. So, how do you get back to Earth? This isn't some movie plot. This was a real life-or-death problem that NASA had to solve.
And this really shows you the sheer scale of the challenge we're talking about. I mean, the trip home was over 3 days, 250,000 miles through, well, nothing. If you were off by just a tiny, tiny fraction at the start, you could miss Earth completely. Just drift off into space forever. The stakes? Yeah, they couldn't have been any higher.
So let's just get into how dangerous this whole trip really was. It'll make it really clear why having a rock-solid backup plan wasn't just a nice-to-have, it was absolutely critical.
I love this analogy. It's just perfect. It says, trying to hit Earth's atmosphere is like trying to hit a dinner plate from a mile away. Think about that. Come in too steep, you just burn up. But if you're too shallow, you literally bounce off the atmosphere and back into space. You've got to hit this incredibly narrow window, this entry corridor. It's an almost impossible target to hit.
You know, the real genius of those NASA engineers was their mindset. They were completely obsessed with the what-if game. The paper's own introduction says it all. They were thinking, okay, what if the radar on the ground fails? What if we lose all comms? They planned for every single thing that could go wrong. And they knew they needed a plan that let the astronauts save themselves.
And that's where the solution comes in. It's this really elegant, almost shockingly simple method that the astronauts could do all by themselves, right there in the capsule. And here it is, the actual report, NASA Technical Note D6343. And check out the authors. This was co-written by the one and only Katherine G. Johnson. Yes, that Katherine Johnson. Her calculations were the backbone of the space program. And this paper, this laid out the exact procedure that could bring a lost crew home.
So the whole idea was something called onboard guidance. It's pretty much what it sounds like. It meant the astronauts wouldn't be just guessing. They could actually use what they had on board, their own eyes, their instruments, some special charts, to figure out exactly where they were and which way they needed to go. It was, quite literally, their lifeline.
Okay, so how did this thing actually work? Well, the answer is ancient. It's the same way sailors have crossed oceans for centuries. You navigate by the stars.
Wow, check this out. This diagram is straight from the paper, and it shows you just how brilliant this was. It's so simple. The astronaut just uses an instrument to measure the angle between the edge of the Earth, the limb as they call it, and a specific star that they already know. And that one little measurement, that angle, that was the key to getting home. And this is the whole thing, right here in just 4 steps. Seriously. First, you take that star sighting. Second, you look at a chart that tells you what the angle should be at that exact time. Third, you see the difference between your number and the chart's number, and bam, that tells you exactly how far off course you are. And finally, you just calculate a little engine burn to push you right back on track. It is so elegantly simple, it's incredible. Now, to make sure this thing was truly bulletproof, they actually tested it against 2 different scenarios. The first one was like, okay, you've already made a course correction, but maybe some small errors have crept in. The second one, that was the real nightmare scenario. It assumes you had a big screw-up right when you left the moon, and this onboard fix is the only navigation you've got for the whole trip home. But, you know, this all leads to the one huge question, right? Was it actually accurate enough? I mean, could this really save them? This is it. This is the target they had to hit, plus or minus 1 degree. That's the entire window between a safe return and total disaster. There was 0 room for error. None. And the numbers here, wow, they really tell the story. Their analysis showed that without their correction, you could be off by as much as 122 kilometers by the time you reached Earth. But after using their method, that error shrinks all the way down to just 17 kilometers. That's not just an improvement, that's the difference between life and death. So the conclusion was crystal clear. The math worked. The simulations proved it. An astronaut with just a few simple tools and this procedure could get themselves back into that tiny little entry corridor. They could get home. Now, thankfully, they never actually had to use this emergency procedure. But the fact that it existed, that tells you so much about what made the Apollo program successful.
And listen to this. This is straight from the paper's own conclusion. It says, it was shown that the method which included the onboard mid-course correction is far superior. This method has much higher accuracy in controlling the entry angle. I mean, their work wasn't just a backup plan, it was a huge confidence boost. It was the ultimate safety.
Because really, when you think about it, for every amazing launch we watched on TV, for every famous footprint on the moon, there were thousands and thousands of pages just like this one. Just quiet, brilliant work from people like Harold Hamer and Katherine Johnson, planning for disasters they prayed would never happen. That commitment, that's what made it all possible.
It really makes you wonder, right? As we're looking to go back to the moon and even onto Mars, what are the invisible calculations, the backup plans being written right now that are going to make tomorrow's impossible journeys seem, well, almost routine?